Today we're going to continue our discussion for software design pattern. Okay, you see in the screen we have already covered adapter, composite, observer, state. Do you still remember when we recommend to use what? Out of these four we covered so far. So let us go ahead and just remind you about each one of them. What do you think about adapter? Guys, when we recommend to use adapter, which circumstances, scenarios you as a software developer would like to use adapter? Anything from the floor? Yes, please go ahead. Okay, so you need two incompatible objects. Yeah, changing an interface of one object to other interface the client accept. Thank you. So whenever we have, for example, some legacy code, or you have built some code before and you test it and you declare robust and you like to use it in some similar situation, but the interface of that old code different than the interface expected in the new application, in this case, we recommend to use adapter so that you can change an interface of one object to other interface accepted by your client. Thank you. What about composite? What do you think, guys? When we recommend composite design pattern, I just need to remind you, composite is simply try to model some components, and this component can be individual item or a collection of items. And that design pattern makes sure they can access these components, whether it is individual item or collection of items, in uniform interface. So when we recommend to use this design pattern, what do you think? All right, so if you have some situation like we can model the application or the requirement in some hierarchical relationship among the objects, then our choice here to use composite. And I give you the example of this type of hierarchy when I say that when we discuss JavaFX and say that internally the JavaFX manage all its control through a tree, and the tree has a root, one unique root, and the root has some branches. The branches themselves can have other branches or other leaves. This is what we call it hierarchy or architecture. If we have such scenarios, composite design pattern is your solution. Do you still remember observer? Yes, go ahead, please. Yeah, but did you mention that it represents one-to-many relationship?
Yeah, like there's many small ones.
Yeah, so yeah, originally is to model application that like to manage objects in the form of one-to-many, and the many part, the object that involved in the many part, they need to notify the other object whenever they have a change in their states. So one object, if that object changed the state and need to reflect upon these changes among the other objects without the need to have tightly coupled with other objects, observer design pattern is the solution. What about state? when we recommend to use a state design pattern. Do you remember the vending machine? Please go ahead. Yeah, so if you have an object, complex objects that have heavy if-else statement or conditional clause, and you need to manage that complexity, then exactly we use state design patterns. And we say that whenever we have an object that can change its behavior based on changing its state during the running time. And when we use a state design pattern, it looks like the object changed its behavior during the running time, and it looks like they're changing its class. So, and we also say that whenever you have an object that has complex conditional statements, we use state design pattern. So thank you for your input. Today we need to talk about Singleton. All right, so what is Singleton? As we said, we start by quick motivation. Here in the slide, we say it's important for some situation, some classes would like to have one instance only. If that makes sense to you, guys? We always say object-oriented programming, we build the class so that if the class may have multiple instances, then we say this is a good candidate for a class. And now we have the situation that we say in some scenarios, we need a class that has one instance only. What do you think when we need such a scenario? Any input from the class? Let me ask the question a different way. Assuming that you guys are building a real world application. And in that application requires, based on the security requirements, you need to store and record every single transaction. For example, when the user logged in, you need to store some information which user has logged into the system, when they logged out. And if that user selects a specific function in the main menu, you need to record this selection and how long they stay with that option, and what did they add in, for example, adding information or deleting information. So if you would like in your application to record every single transaction, and we call it audit trail, you need to audit every single transaction in the application. What are you going to do? Are you going to save this information in your database? The answer is yes, right? Okay, this application is multi-user application. How many files you want to create to store this information? A lot? Or one central file? Yes. Okay, it's all about recording and storing. It's all about write, not read. Everyone needs to write this information. All the transaction happened by one user or 100 users at the same time, they need to store this information so that we maintain a log. We call it audit trail. Are going to be only one file or multiple distributed files? One file. That makes sense. How can you guarantee that? Because we are using object-oriented programming. How you can guarantee that when you define that entity class to store this information, you won't have only one instance? Because see that we need to have a centralized location. Everyone save this information on that entity class. In this situation, we need one and only one instance. Correct? How can we achieve that? Yes.
But if you have everyone able to access like one single instance of an object, they also also not delete data, which then like goes against the point of logging everything? Like if they like, I don't know, like for example, if there's like a police database where like they have a bunch of like stuff. Like,
Perfect. This is a good question, by the way. Yeah, you said that. Yeah, so the question said that here, we said that we need one center file, but the question is how can we control someone corrupt these files, right? Tell me, which is better or which is easier? To protect one single file or to protect distributed multiple files? Exactly. So you respond to that question. Now, if you need to add some procedures to protect one file, to protect against corruption, you're going to do simple, easy step to protect one file. Easy to manage and to protect. Singleton class give us the opportunity that make sure that we have only one instance and also give us opportunity to build functionality to protect it as well. So we spend effort on one file or one table or one class to protect it against multiple attacks. Way easier to consider different type of attacks on different type of files located everywhere. So this is the purpose for Singleton. And it says here in the slide, it's important for some classes to have exactly one instance. And by the way, this is one of the most common questions you may see from any interviews. I'm talking about security, talking about how to maintain log or audit trail, how to later on have all this information available, accessible from anywhere to maintain some analysis, to do some AI on it. Then it's easy to be in one file, not in multiple different files, different locations. Okay, so here I give you some other examples. I just mentioned about log system or audit trail. There is 3 other examples here. I give you example like the computer. Any computer, they have audio out device. Whenever you need to play some sound, the operating system are going to forward that sound to that audio output. The operating system need to make sure that that object has only one instance, because we cannot have multiple audio outputs in one device, in one computer. To control that, the operating system implement the audio output using Singleton as well. And other example also related to operating system management, when they manage multiple printer connected to one computer. All the computers has only one spooling or a spool driver. All the print job forward to one location. We call it printer spool. We cannot have multiple instances of that in that hardware. So operating system required to use Singleton in order to control such device, to make sure that we have only one instance, although we may connect multiple printers in the computer. And also the file system. All of you are familiar with exploring the files, file explorers. That file explorer need to be implemented as one instance, an object that has only one instance, because we cannot represent the file system in different way in one computer. Okay, so the question now, how can we achieve that? How do we ensure that the class has only one instance and that the instance is easy accessible? I think we mentioned that. We see that the solution is using Singleton. What does the Singleton do? The Singleton class going to be responsible to create itself. Did you hear that statement, guys? Singleton, when we define a class as a Singleton, no other classes can create instance of that class. the only class responsible to create instance is the class itself. So the class going to be responsible to create instance to itself. That means they need to control the use of the keyword new. So let us see how can we do that. But before that, we need to just again to say the intent for this design pattern. So it's to ensure that only one instance of a class is created. I think we mentioned this number of times. And also to provide global point of access to that object. See that if you have multiple users, all of them need to store specific information to one central point. That means we need to provide easy access to such global database or point. How can we do that? Look at the screen. This is the design. Very easy, simple design. But the trick here, look at that. This association line. Now we have a class. I named the class here as Singleton, but you can name it the name you like. And look at that. The association from the class to itself. And this again, the first time you see association link to the same class. And we gave it a name here. This is the end role of the association. And then we have here the constructor. You guys need attention. Look at the screen because this will tell you how to convert any class to Singleton class. The first step is to define the constructor as private. Did you hear that? All the time when we create a class, we define the constructor of the class as public. This situation, the only situation we need to define the constructor as private. The reason for that is to prevent any other object or any other class to use the keyword new. So the first step, define the constructor as private. Second step, provide a method, a public method that can create an object to itself using this self-association line. We define a variable. In this example here, I call it underscore instance of type Singleton, of type the class itself. And this method, get instance, it's a public method to use the keyword new to create an object of the class itself and assign the reference of that object to the variable underscore instance. This is the whole idea of the Singleton. In addition, you can add any methods like we discussed before. If you need to protect against any corruption, you need to make sure that who can access, who can delete, who can write. You can add extra methods inside that class. Okay, so there is two different ways to implement this method, get instance. The first one, we call it lazy instantiation, using Java built-in locking mechanism. So let us look at that code. We define that link, the association link to itself. I call it here in this example underscore instance of type. Look at that, of type the same class. The class name is called Singleton, and the type of this variable also Singleton, and defined as static, but not final. And look at that. Singleton constructor is defined as private. And the way we implement get instance, we use built-in Java locking mechanism. We call it synchronized. The keyword synchronized here, it says that define this method with locking mechanism. Did you hear about that before? Perfect. So we said that the reason that we have a Singleton is to have one center instance, one single instance, and easy accessible from anywhere. That means we would expect too many users access this class or this object at the same time. And we may implement multi-threads. We may have multi-threads running at the same time, multi-processor, multi-servers, multi-computer running at the same time. All of them need to call the method getInstance. But we need to make sure that getInstance is executed by one request at a time. Cannot be executed multiple requests at the same time. Because in this case, when we say multi-threading, that means we may have the same multi-request to the same method at the same time. We need to prevent that. We need to make sure that if we have too many requests to one method, only the first request can execute the method. And then when the first request done, then the second request can execute. How can we achieve this? It's easy, simple, by adding this keyword, synchronized, in front of the method name. So for the lazy instantiation, we use locking mechanism, which is built in Java. We define getInstance as static, synchronized, and return object of type singleton, because this method is responsible to create the object of type singleton. Look at the statement here. It says that here, using if statement, if this variable is null, now create a new object. Now I'm allowed to use new singleton because I am inside the class itself. This is defined as private, but the inner method has access to this private attribute. So I'm going to call to create a new object and assign it to instance and return this instance. And if this is not null, then we don't need to create it. We just return it. That means the first request to getInstance will create the object. All other requests will just return it. That means we have only one instance, one creation for the object. And then we can do anything else here, any other method that we would like to add, like adding some security mechanism or adding some business logic can be added on the class. How we get that instance? Again, this method defined as a static, so that we need to know the class name and call the method. The class name singleton, call the method called getInstance, and then that object has some other methods. We can call this method by name or name the method after the dot. Look at the code class and let me know if you have anything here unclear. It's very easy, simple statements, but you may have some questions. This is called lazy instantiation. The other one is called early instantiation. It doesn't require locking mechanism. It just utilizes the meaning of the keyword final. Look at this in the screen. So what we do here, we define this association link and give it a value, and that attribute that has that value defined as static final. Do you still remember the meaning of final? With Java? Yes. Cannot change, it's constant. So if you need to define a constant in Java, we use the keyword final. And when we define a final to any attributes, that means we have to give it a value, we have to initialize it, and we cannot change it after we initialize its variable. So when we say here static final, that means it's static as a level of the class, and final, that means once we give it a value, we cannot later on change it. So that value is the object of its class. So I give a value, for instance, by creating an object, and then we cannot change it. And then we offer the method get instance as public because the singleton constructor is private. And this is going to return the value for this final variable. And then anything else. I have a question for you now. What the difference between this implementation and the previous one? The previous one says here, when we call get instance, we create the object. And here, once we define the class, we create the object. What does it mean? Yes. The first one, check if it's null before it's not. If it's null, you create it. If not, just return. The second one, create it anyways. That means if we don't need to use it, still create it. When we use it, we use it when we call the method get instance. So the first implementation, lazy instantiation, will create the object only when we call the method get instance. That means will not be created by default. Will be created only once we have the first call of the get instance. The second one, even before we run the statement get instance, the object is created. Maybe we don't need to use it, but still the system will create. So if in your implementation, you're going to use the object, you are sure going to use that object anyways, we recommend to use early instantiation. But if it's not, use the first one, which is lazy instantiation. But both of them, again, we're going to define the constructor as private, and you have to provide get instance method. Okay, when we recommend to use it, I think we described that at the beginning of the class, when there must be exactly one instance of the class and it must be accessible to client from well-known access point. Here in the slide, I give you the example for logger class. We described that at the beginning for the motivation part. And also provide here other useful implementation for it. When we have shared resources, and we need to make sure that this resources is shared or managed when we have too many users have interest to that shared resources, because we can implement locking mechanism. Okay, so far, guys, do you have any question? Okay. There is some variation for singleton design pattern. We said that singleton make sure we have only one instance of the object of the class. In some situation, we may need limited number of instances of a class. So we know that when we create a class, we may have unlimited number of objects. Singleton ensure that we have only one instance for the object. Singleton can also give us option that we can say, I can create n number of objects. Like say, one class may have only 4 instances, no more. So also singleton can be revised to do such things. For example, your laptop, how many USB port in your laptop? 2, 3, 4, up to? Mac has 4.
Well, it doesn't have
USB-C.
Yeah.
Still, we call it USB. USB-C, 4. You have 3, right? Some other has only 1 or 2. Do you know that the operating system that manage this port using singleton, since your hardware has 4 USB-C ports, the operating system needs to control this 4 and only 4, no more. So how can you make sure there is no extra instance to the USB port, the hardware part, they use Singleton. And here in this example, I'm showing you that we can use Singleton to make sure that we have up to four instances only, no more. Again, we have a class that refer to itself. This example have 3 ports, not 4. So 3 port 1, port 2, and port 3. That means 3 variables. Look at the code here. We have here USB port 1, port 2, port 3. We are using here lazy instantiation. All of them has null values. And then we offer here get port 1, get port 2, get port 3. And for the first time, all of them are controlled by the synchronized keyword. The first request for the first port, we're going to create the object and return it. The second request to the same port, we're going to use the same instance. We'll not create a new one. And for each port, we have one instance only. Look at that code, because we need to do something similar in one of our examples that we covered before. It's easy. Constructor, convert it to private, provide the method called get instance or get any kind of service. Okay. Now, remember state. When we discuss states, I need to show you something in the slide. When we talk about states, if you recall that, okay, for this class, look at this. This is the state. Guys, need your attention, please. We said that each of this state class is recommended to be implemented as a singleton class. How can we do that? Let us see. This is the code for that example, the state. We have the vending machine. Look at the slide. So this is the code for the vending machine example. We have the vending machine that create the object vending, and we have here the state 0. Look at the state 5. Based on the slide, this exactly as we have in the slide. But this is not a singleton. Now I'm going to explain to you how to convert singleton in a very easy, simple way. If this is the class and it need to convert it to singleton, look at that. That class 0. Step number 1, define attributes, refer to itself. I call it here state 0 with little s of the same class name as a static. And make the constructor as private. Step number 1, create the attribute, refer to itself. Step number 2, make the constructor as private. Step number 3, provide a method that return an instance of that object, the value for this link. If it is null, if that attribute is null, use the keyword new with this constructor, assign it to this attribute, and return it. This is the 3 steps. Call this object as we have it here, as we have it in the vending machine. When we need to assign the new state, look at this. Instead of writing state 0, I'm calling the class name and invoke the method getState. This is different than something like this. New state 30. This is not singleton. because I'm using the keyword new outside the class 30. But for the class 0, in order to call the class 0, I need to call the method getState using the class name of the state 0. Okay, guys, so I think this is end of our class today.